Poetry and artificial intelligence, it still feels, well, a bit like oil and water to many of us, doesn't it? We tend to think of poetry as something uniquely human, needing deep emotion, those subtle metaphors, that almost mystical sense of rhythm. But what if a machine could go beyond just mimicking? What if it could actually create something profoundly poetic? Today, we're diving deep into exactly that question. We're looking at a really groundbreaking new system. It's detailed in a paper just published today, July 22nd, 2025, by Austin Maverix. It's called the Poetic Fuzzy Inference Architecture, or PFIA for short. Our mission in this deep dive, to really unpack this novel hybrid system. It's designed to emulate, maybe even extend, human poetic thinking. We're going to explore how it tries to balance metaphorical richness, rhythmic coherence, and that tricky affective resonance, and what this might mean for the future of AI creativity. So, okay, let's unpack this a bit first. Why has poetry specifically been such a tough nut for AI to crack, such a persistent challenge?
Yeah, that's a great question. And it really gets to the heart of where traditional AI methods have kind of hit a wall. See, most existing models, when you ask them to generate poetry, they basically just treat it like predicting the next word in a sequence, like a statistical guessing game.
Just pattern matching.
Pretty much. But real poetry, it's so much more than just syntax or finding the statistically likely next word. It's about symbolism, it's about ambiguity, that sort of fuzzy meaning, and capturing those subtle emotional shifts over time. Traditional AI often falls short because it just doesn't have that deeper cognitive integration. It struggles with the fluidity, the fuzziness of meaning, and how emotion can change a word's whole feeling.
That makes perfect sense. It's not just getting the grammar right, it's getting the vibe, the unspoken stuff right.
Yeah.
Which feels, yeah, incredibly human. So this is where the Poetic Fuzzy Inference Architecture, PFIA, comes in. How does it fundamentally change the game? How does it propose a new way for machines to approach poetic cognition? Because this is where it gets really fascinating.
Right. PFIA is genuinely a novel hybrid system. It's not just predicting sequences. Instead, it fuses fuzzy logic with symbolic processing and, crucially, rhythmic processing. And it does this within a recursive framework, meaning it can kind of learn and adapt as it goes. It's specifically designed to try and emulate and perhaps even push beyond how we humans approach creativity. It directly tackles those limitations of older AI by understanding that meaning isn't always black and white, and that a poem is more than the sum of its words.
Okay, a hybrid system, fusing fuzzy logic, symbolic, and rhythmic processing. That sounds complex but powerful. Could you break down the key innovations for us, sort of the main components that make PFIA work?
Absolutely. Let's think of PFIA as having several interconnected parts, like specialized brains working together. First, you've got fuzzy logic. This is really key. It allows for connections between symbols, between words or concepts to be graded, not just on or off.
So not just related or unrelated, but kind of related or strongly related.
Exactly. It allows for shades of meaning, much closer to how human language actually works. It captures that fluidity. Then there's the symbolic association matrix, the SAM. Now, this might sound a bit technical, but imagine it like the AI's dynamic mental map, or like a thesaurus that changes based on mood.
Right.
It's a system where the strength of the connection between any two symbols represented by a value between 0 and 1 isn't fixed. It actually updates dynamically. It changes based on the poem's current emotional tone, its affective state, and also its rhythmic needs.
Huh. So it's like a word isn't static, it has a kind of mood, and that mood influences which other words it wants to be near in the poem.
Precisely. And building on that fuzzy foundation, PFIA uses probabilistic semantic webs. These help it represent ambiguity and metaphor. This is how it can embrace the, beautiful uncertainty and multiple layers you find in good poetry. It doesn't try to force one single literal meaning. It understands that the moon is a lonely eye isn't literally true, but it works poetically.
It gets the metaphor.
Yes. And then we have rhythm-aware logic flows, or RAX. This part dynamically brings in metrical constraints. So the AI isn't just spitting out pretty words, it's paying attention to the rhythm, the cadence, the meter, the tempo.
Like it has an internal metronome.
Kind of. It ensures the poem sounds right, which is fundamental to poetic structure. And finally, maybe the most intriguing part is the recursive mythopoietic module, or RMM. This module is about how poetic themes or motifs emerge and evolve over time within the poem. It has this motif graph that changes based on how strongly symbols connect, their emotional alignment, their rhythmic harmony across different themes. It's what lets the poem develop a kind of emergent narrative identity, like a story unfolding subtly through the images and feelings.
Wow, that RMM sounds incredibly sophisticated. Like the AI isn't just writing lines, it's building a mini world, a mythology within the poem itself. So with all these complex pieces interacting, how does the system actually, put words down, form a line of poetry? Can you give us a simplified walkthrough of the algorithmic flow?
Sure. Think of it like an iterative process, a kind of dance between these components. First, the system updates that symbolic association matrix, the SAM. It's constantly tweaking those fuzzy connections based on the poem's current state.
Refining the word relationships.
Right. Then it applies the rhythm-aware logic, RALX. This step kind of filters or prunes the possible word choices based on those rhythmic constraints. Does it fit the meter? Does it maintain the tempo? Making sure the line flows properly. Next, it updates the recursive mythopoetic modules graph. This takes into account the poem's evolving emotional feel, its affective state, and those rhythmic decisions it just made. This helps ensure the themes and the overall emotional journey are developing coherently.
Keeping the bigger picture in mind.
Exactly. And finally, with all that context, it synthesizes the words. It picks the ones that are most metaphorically resonant and rhythmically coherent to generate the next line of the poem.
So it's constantly balancing meaning, feeling, and sound. You mentioned affective state and emotional context playing a big role. How does PFIA actually quantify and integrate something so human into its logic?
Yeah, that's absolutely critical. The fuzzy inference part of PFIA actively boosts the connection strengths between symbols that align with the poem's target emotion. It uses something called an affective modulation scalar. This basically takes inputs representing valence, pleasantness, unpleasantness, arousal, intensity, and dominance control.
The standard dimensions of emotion.
Right. It uses those to understand a target mood like melancholy or joy, and then it dynamically strengthens links between words that evoke that specific feeling. And for rhythm, the system that RALX component doesn't just demand perfect adherence to a meter. It balances metrical fit with temporal compatibility, looking at overall tempo consistency too. This allows for those subtle variations, the slight imperfections that actually make human poetry feel natural and flowing, not robotic.
Okay, this whole system sounds incredibly advanced, which brings up a huge question. How on earth do you evaluate this? How do you rigorously measure the quality of AI poetry, which is so subjective?
That's a really important challenge, and the paper proposes a quite elegant solution. The Dimensions of Poetic Intelligence Framework, or DPI. It's designed to be a rigorous, multidimensional benchmark. And what's unique is how it balances computational metrics, things the computer can measure, with essential human evaluation. Because ultimately, poetry is for humans, right?
A mix of machine metrics and human judgment.
Okay.
So what are these dimensions it uses?
There are three main continuous dimensions in the DPI framework. First is poetic depth, PD. This looks at things like metaphor density, how rich is the figurative language. It also measures fuzzy entropy.
Fuzzy entropy, what's that?
It's basically a measure of ambiguity or uncertainty in the symbolic connections. Good poetry often allows multiple interpretations, right? Fuzzy entropy tries to capture that. And PD also looks at semantic drift. Does the poem stay focused thematically, or does it wander off randomly? The second dimension is rhythmic coherence, RC. This is more straightforward. It assesses how well the stress patterns match a target meter, tempo consistency, things like that.
Musicality.
Exactly. And the third dimension is affective resonance, AR. This evaluates how well the generated emotion aligns with the intended motion. But crucially, it also folds in human effect ratings. They actually have human panels read the poems and rate the perceived emotion using standard scales, like Likert scale.
So it's not just the AI thinking it's sad. Humans have to feel it's sad too.
Precisely. That human validation is key.
That's a really comprehensive way to try and quantify something so elusive. So the big question then, how did the PFIA prototype actually do? When they tested it against older models, did it hold up, especially with those human judges?
It performed remarkably well, actually. They built prototypes using standard tools like PyTorch and NetworkX. And they tested them against traditional baselines, simple Markov models, and also recurrent neural networks, RNNs, using a collection of sonnets as the testbed. The PFIA prototype significantly outperformed both baseline models across all the DPI metrics. And, maybe most tellingly, it scored much higher in the human creativity ratings. Just to give you a snapshot from their results, table 1 in the paper, the PFIA prototype hit a poetic depth score of 0.76, rhythmic coherence of 0.81, affective resonance of 0.73, and importantly, a human creativity rating of 4.4 out of 5.
Wow, 4.4 out of 5 from human judges. That's high. How did the others compare?
big difference. The Markov model got only 2.8 on human creativity. The RNN baseline did a bit better at 3.1. But PFIA's 4.4 is a really significant jump. The other scores show a similar gap. PFIA was way ahead on depth, coherence, and resonance compared to the baselines.
Yeah, that jump in the human creativity rating, specifically from 3.1 for the RNN to 4.4 for PFIA, that's really striking. It's not just incrementally better, it seems to be tapping into something that resonates with human perception of creativity in a fundamentally different way. What do you think explains that? What's PFIA doing that finally cracks that code where others didn't quite get there?
Well, I think it goes back to the core design philosophy. PFIA isn't just trying to mimic surface patterns. It's attempting to model the underlying processes of human poetic cognition, that interplay of fuzzy meaning, evolving emotion, and rhythmic structure. When an AI can start to grasp those deeper layers, it moves beyond just being a clever parrot. It starts to show something that feels more like poetic intent, and I think humans intuitively pick up on that and rate it as more genuinely creative.
So it feels less random, more purposeful.
Exactly. And if we look at the bigger picture here, PFIA really could represent a paradigm shift. It's embedding poetic cognition deep within the AI's architecture, not just adding it as a layer on top. This hybrid approach, blending logic, symbols, rhythm, emotion, it enables a kind of emergent creativity, a more authentic emotional expression, and fine-grained rhythmic control that we haven't really seen before. This work, I think, lays a foundation for what the paper calls hybrid human-machine poetic minds.
Hybrid human-machine poetic minds. That's quite a phrase. It sounds both exciting and maybe a little unsettling. What are the broader implications? Where could this kind of technology lead?
Oh, the potential applications are really broad. Think about the creative arts, first off. New tools for writers, musicians, maybe even visual artists, enabling new forms of human-AI collaboration. Then there's affective computing, human-computer interaction. Imagine machines that can understand and respond to human emotions with much greater sensitivity and nuance.
Like more empathetic chatbots or companions?
Potentially, yes. Also, education. Think of AI tutors that can help students engage with poetry by generating examples tailored to their specific emotional understanding or learning style. And it definitely pushes the boundaries in cognitive science, giving us new computational models to test theories about human creativity itself. Looking even further out, the paper outlines a really ambitious vision. Things like multimodal integration AI that combines text with visual or auditory cues for poetry, creating richer, maybe synesthetic experiences.
Yeah.
Neurocognitive collaboration, actually validating these AI modules against human brain activity during poetic tasks, that could refine the models incredibly. They also talk about using more advanced AI like graph neural networks for even more dynamic symbolic reasoning, making the AI potentially much faster and scalable, and adapting this for cross-cultural poetry, supporting different languages, different rhythmic traditions from around the world.
It's a huge vision. The paper itself calls PFIA a scientifically plausible, conceptually coherent, and radically innovative framework for poetic cognition. But this brings us back to a fundamental question, maybe the fundamental question here. What does it mean for us, for you listening, when machines can not only generate poetry that's expressive, rhythmic, emotionally nuanced, but can also dynamically evolve themes, create meaning through this recursive mythopoiesis? Does true creativity still need a human soul, a human consciousness? Or can it be formally engineered? Can it emerge from complex algorithms like these? And looking forward, how might this kind of AI reshape our very understanding of what it means to be an artist? Or if you used to appreciate art? These are pretty profound questions to ponder, especially as that line between human and machine creativity seems to be getting blurrier all the time.